Hi guys, I hope you all are doing great. My name is Raghavendra and I'm a solutions architect and DevOps consultant. If you saw my last week's post about InfraCodeBase, for the people who did not see it, let me explain. InfraCodeBase is an AI-driven infra automation engine that understands real enterprise architecture. As I said earlier in my post, so in my previous post, I gave you a small glimpse of all the benefits we gain from the tool and how it is a very useful tool for any organization, DevOps or DevSecOps engineers, and even architects. So here we can not only create Terraform code, we can create Pulumi, OpenTofu, CloudFormation for AWS or Bicep, Python, you just name it. So today I am going to show you a demo on how useful really this infra code based tool is. So let me quickly get started and share my screen.
So first, let me log into InfraCodeBase tool. So this is the home page, guys. So as you can see here, we can create our own team by inviting people. We can create multiple workspace here, and we can connect to many different tools. So we can connect to all the cloud providers as InfraCodeBase has very good tool registry backed by the MCP servers that extends AI agent capabilities with all cloud provider integrations. We can connect with Atlassian products like Jira, Confluence Pages, uh, Azure DevOps, GitLab, and even Notion. That's great, right? And believe me, the team is working to integrate many more, and we can see significant tools to integrate with in coming days. So let's get back to our use case. So I will get started by creating a new workspace. Just click on this plus button, and as you can see here, we have landed to a page where we can create our workspace, and we can either start from scratch or we can import our existing code from GitHub and improvise it. In our case, we will proceed with start from scratch, and I will give a workspace name. Uh, let's say Azure use case 1. I'll just give a small description of like DevOps use case. However, this is a optional field. Next we see is workflow. Uh, this is another amazing feature here, but we will not be covering this in today's video. But I will be covering this in detail in our next video. Next field we have is the visibility where we have private, internal, and public. We can keep this workspace as private or internal within our team or make it public. So I'll choose as private and click on create workspace. So once our workspace is ready, we can get started. The UI is pretty much simple and easy to use. Uh, Here we have add files section where we can add any type of files we need. You can see connected with GitHub logo here. By the way, I have already integrated my GitHub account, so that's why it is showing connected. Uh, Next, we have view workflow, which is disabled in our case because we have not selected any workflow. Next is add agents. Here you can see I have already added GitHub agent, and I can add many more by adding by clicking on add tools. So we just click on add, it will get added. So I'll just get back to my workspace. Okay, so now the fun begins. Let's get started. Let me show you how simple yet powerful this InfraCodeBase tool really is. So today I'll be creating an enterprise scale production grade with best security practices Terraform code. Let me show you the architecture diagram which we will be using today. So before I explain what this architecture is, let me execute this. Uh, because like when the execution starts, I can explain it. So let me add the image first. Yeah. So here's what I'm going to do. I'll just give a prompt. Use Terraform best practices throughout the sorry, implementation. Create using Terraform modules for every component and follow best security practices. I would say build the architecture for Azure. Let's say adding AWS as well. Okay, and AWS. Create one folder each, one folder for each cloud provider. I would like to follow the well-architected framework for both Azure and AWS. So for Azure, follow, let me find the URL. Follow this, and for AWS, follow this. Now, after building, run Terraform format and Terraform validate on both cloud codes to ensure configuration correctness. Uh, let's ask for the cost breakdown and cost comparison for each cloud. Give me cost breakdown and cost comparison for each cloud. So I just added the architecture diagram here and given the prompt on what I need and just click on enter. So let me open the thing. I have started this at 9:56 a.m. CET. So let's see, monitor how much time this tool takes to complete this task. So what this tool does is it will analyze the architecture diagram. We fed it, start working towards it. I will come on to that in a while. Let me explain what we are creating first. So this diagram shows a complete DevSecOps pipeline for deploying container workloads to AKS. Uh, the workload starts from the developer authenticating through Entra ID and committing code from VS Code or Visual Studio into GitHub. GitHub Advanced Security kicks in immediately for SAST, dependency scanning, and secret detection. Uh, Once a pull request is created, GitHub Actions runs a CI job to build and test the application. After approval gates and security check runs, the pipeline builds a container image and pushes it into Azure Container Registry. Microsoft Defender scans the image for vulnerabilities. Azure Policy evaluates both the container and cluster for compliance before deployment. GitHub Actions then triggers the CD stage, the continuous delivery stage, and deploys the image into AKS. Secrets required by the workloads are pulled securely from Azure Key Vault. AKS is continuously monitored through Azure Monitor and Container Insights with logs streamed into Log Analytics. Sentinel can use those logs for threat analytics and automated response. Network level security such as OWASP, ZAP policies is applied inside the cluster and the entire pipeline is visible to the security team through Defender for DevOps. So what this gives you is fully automated security enforced path for from the source code all the way to production grade Kubernetes. So as you see, this architecture diagram is purely for Azure. But I have asked InfraCodeBase tool to replicate this for AWS as well. So what this does is like it will take the similar services available in AWS and replicate the same architecture there. So let us get back here. So as you see, it has created two folders for Azure and AWS is yet to be created. Let us see what's happening. So uh, if you see here, it has created certain tasks for itself after we give the prompt. So here if we see like it is analyzing the Azure architecture diagram. Sorry for this, it's getting updated pretty much quickly. And then it has started to create Azure Terraform modules for with well architected principles which we had given. So once it has completed for Azure, it will move to AWS. So as you see, the first step is completed and it is started to write Azure Terraform modules. So now we can see the creation of Azure Terraform modules are completed. Now it has proceeded to create AWS Terraform modules using the AWS principles. Let us wait for it to update. So we can see it has followed all the uh, correct folder structure. Now if we see it has started to write the modules for AWS. So you see here we have the application load balancer, EKS, KMS monitoring, S3 secrets, VPC. So we don't have to feed it anything. We can just give the architecture diagram and ask it to replicate in any cloud we want. We will wait for this to complete. It has finished writing the EKS and the KMS related files. Okay, so looks like it has already completed the creation of AWS Terraform modules. Now it is running the Terraform format and Terraform validate on both cloud providers, Terraform files. So this is the great feature, right? If there is any issues with the formatting, it get resolves and we get the right code. So let us wait for this to complete. So it is checking on each and every file individually. So let us wait for a few minutes. And trust me, it's just been 10 minutes. In 10 minutes, it has finished writing code for AWS and Azure. It is running Terraform format and validate on each and every Terraform files. So as we can see here, it is now running Terraform format and validate on both the implementations. Few more minutes and we will be done. So, so if we see here, they are telling us that it is seeing some circular dependency issue and it's going to fix it by removing the depends on clause. So if any issue is found in the beginning, it will just catch it and fix it for us. So we don't have to face any issues later on. That's great, right? Let us wait. It's going to fix the key vault module for the similar issues. So let's wait. So that's completed. Now it is creating the cost breakdown and comparison analysis for the architecture what we have created using Azure and AWS. So let us just have a look at the files or Terraform files which it is created. So let me move into AKS. So we see everything is well formatted and as per expectations. This is very good. I mean, like there is thousands of lines of code with written in minutes. Wow. So few more minutes and we will be done. Okay, so it is done. So we see the time is now 10:10. We had started it at 9:56 a.m. and it is like now 10 past 10 a.m. So we have all the details with the scripts and even the cost breakup and the comparisons here. So you can see all the required details present here, what all it has performed, the key differences and the advantages of Azure and AWS. So guys, this was super quick. So let me show you one more thing. Let me ask this: how big is the code base, and how long would a real engineering team would take to build this from scratch? So it is now just calculating the number of lines. So as we can see, it has started to count the total number of files present in this total code base, and we will be getting the report in few minutes. So if we see here, it has given the report to us. There are total files 63, 61.tf files, 2.md and 2.example files. Total lines of code is 4,358. Uh, in Azure, it is 2,163 lines, 7 modules, and AWS we have 2,195 lines and 11 modules. And these are the uh, modules which it has written for both AWS and Azure. So this number of days any engineering team would take to complete for both AWS and Azure. So you have all the details here. So if we see if the cloud architect, the team cost analysis is here with respect to the US market. A cloud architect with this package may take 12 weeks to complete this. A senior DevOps engineer we may need two, may take 12 weeks. A security engineer may take 12 weeks. So total cost for the company would be around $134,000. And if it is a mixed team, like we may face with like senior, mid-level, and junior engineers, along with the architect, this may cost around $229,000. So we have all the clear-cut report here. We can ask any other reports we need. So now we have everything ready. So guys, before we do the PR, so we have to just click on this connect to GitHub, and I will just say do the PR. So as we see here, it's telling us it will create a new GitHub repository for our multi-cloud DevSecOps infrastructure and then create the pull request. So it has started to push our code to the new repository. Frankly, I'm just amazed with the capabilities of this tool. And trust me, this is just uh, one small execution I'm showing you, but in coming days, I will show you multiple different real-time scenarios. So uh, please follow me for more such videos. So it is completed. Let me come here to my Git repository and refresh the page. We can see here the new repo is created a minute back. Multi-cloud DevSecOps infrastructure. I am on my main branch and I have just a readme dot markdown file with git ignore. But where is my code? It is in feature branch created. So you can see all the codes are present here with all the modules, AWS as well. So I believe, okay, it has placed the cost analysis here. So we can see all the details here for Azure, for AWS, the cost comparison reports is available here as well. So
So, guys, that's the walkthrough. The big takeaway here is simple. AI is not here to replace infrastructure as code or the people who build it. It's here to take the grunt work off the plate. So, tools like InfraCodeBase can read an architecture, understand best practices, apply security standards, and generate clean Terraform or Bicep the way a senior engineer would, only a lot faster. So what this really means for the team is like they get to spend more time on actual designing or performance or security or less time fighting the boilerplates. And honestly, that's where our real value is. I will keep sharing this real world use cases like this because there's a lot more we can do using this platform. So if you want to follow me along, details are in the description. Thanks for watching, and I will see you in the next one. Thank you.